We're all familiar with suburban phone towers, the antennas we see on towers or on the tops of shops or other buildings. These are called outdoor macro cells, and they're everywhere in our suburban landscape. Most people would think that these towers deliver all our mobile phone coverage, and in rural or remote areas and lots of suburban areas, that's actually true. However, in an overall sense, only about 60% of mobile phone coverage in Australia is delivered by these macro cells. In buildings that are more than 20 stories high, or in locations where signal is impacted by terrain or by building materials, these outdoor macro signals do not provide sufficient coverage. In heavily populated locations such as shopping centres, airports, sports arenas, hospitals, office buildings and so on, we expect and often get fabulous mobile phone coverage. This is made possible by two in-building communications technologies: distributed antenna systems, or DAS, and cellular repeaters. Distributed antenna systems derives the name from the fact that they are actually built with macro cell technology, reconfigured to feed many small antennas that are distributed throughout the building. These distributed antennas, located all over the property, provide good signal in close proximity to the mobile phone users, and this results in reliable reception. The DAS system provides guaranteed coverage and guaranteed data throughput because they are built to strict technical standards which are published and controlled by the Mobile Carrier Forum, the MCF. A lead carrier connects its core network directly to the building's DAS and operates and maintains it from day one. Connection back to the network core is via secure underground optical fibre links. Before building a DAS, the design must be approved by the lead carrier. Carrier connection is then expensive. It is not unusual for carrier connection costs to be several $100,000 per carrier. The carrier connection for a repeater, on the other hand, is via the off-air signal from a nearby macro cell. They boost and rebroadcast that signal across the coverage area. This relies on having sufficient coverage from a macro cell at the start. Repeaters remain owned and maintained by the property owner, not the carrier, but they still require proper engineering design. In summary, a DAS provides guaranteed coverage but is more expensive. A repeater provides less performance and costs significantly less. Which of these is best for a particular situation depends on a range of factors, including how the space is used, the building layout and the requirements, and the macro coverage. The first step in the process is to undertake a coverage survey and an audit, and from there a suitable design and costing can be prepared. A couple of points in closing. Firstly, we are transitioning to a mobile-only office environment where all connectivity will be via 4G and 5G. This will require DASs to be capable of the latest 5G bands and to use multiple in, multiple out, or MIMO, antenna technology. Commercial buildings will, in all likelihood, require a DAS. Secondly, as mobile data usage rises, increased bandwidth is required in the mobile network. This invariably leads to higher frequencies being used. The difficulty with higher frequencies is that these signals do not propagate or penetrate very well in modern buildings. These buildings are typically constructed for the best thermal efficiency, and they'll have metallised glazing, foiled back panels or well-insulated cavity walls, and the floors are of course made of concrete with steel reinforcing. To compensate, additional antennas will be required. Now, repeaters may initially look attractive financially, but the long-term value of a DAS will often provide a better solution. Finally, it's critical to consider the use case for the current and future occupants, patrons and visitors. Dependable mobile phone connectivity is becoming essential for retail payment transactions, for ordering meals at restaurants via QR codes, for connecting 5G enabled vehicles for security and monitoring, for home security, and so on. Look, I hope this has helped to explain some of the issues around in-building communication.